This is example 3.7.45 from the book. The problem reads, the line that is normal to the curve x squared plus 2xy minus 3y squared equals 0 at the point 1, 1 intersects the curve at one other point. So in order to do this, we're first going to have to find the slope of the tangent line at the point 1, 1. So we're going to have to implicitly differentiate this function. So we have x squared plus 2xy minus 3y squared equals 0. So let's differentiate that. We have 2x plus the product rule here. Here's our u and our v. So plus the derivative of the first, which is 2, and the second, plus the derivative of the second, which is d by dx, in the first, which is 2x, minus 6y dy dx equals 0. So let's get all of dy dx's onto one side and all the other terms onto the other side. So we have 2x dy dx minus 6y dy dx is equal to negative 2x minus 2y. We have dy dx, just factoring that out, 2x minus 6y is equal to negative 2x minus 2y. So if we divide by 2x minus 2y, we get dy over dx is equal to negative 2x minus 2y divided by 2x minus 6y. Let's make a little bit of a look here. So now that we know the derivative for the curve, we need to find the slope of the tangent line at the point 1, 1. So we're going to evaluate this at the point 1, 1. So we have negative 2, our x is equal to 1, minus 2, our y is also equal to 1, over 2 times 1 minus 6 times 1, which is negative 4 over negative 4, which is 1. So now we have the slope of our tangent line is 1, but we want the slope of our normal line. With the normal line, if our tangent line is 1, our normal line is simply 1 over 1, and it picks up a negative. So we have negative 1 as the slope of our normal line. So now let's find the equation of the normal line. We know that we have the point 1, 1 intersects the normal line. So we have y minus 1 is equal to x minus 1 times our slope, which is negative 1. So we have y minus 1 is equal to negative x plus 1. Y is equal to negative x plus 2. So now that we know the equation of our normal line, we need to find the points of intersection between our original curve and our normal line. So to do this, we're just going to plug in our original equation. Everywhere we see a y, we're going to plug in negative x plus 2. So we're left with something that looks like this. So we have x squared plus negative 2x squared plus 4x minus, let's FOIL this out, and we have x squared minus 4x plus 4. So we have minus 3x squared plus 12x minus 12 is equal to 0. So now if we combine like terms, we'll see that we have an x squared, a negative 2x squared, and a negative 3x squared. So we have 1 minus 2 minus 3, we left with negative 4x squared. 4x plus 12x, that's plus 16x minus 12 is equal to 0. So now we can make this a little easier to factor. We can divide out a negative 4. So we'll get x squared minus 4x minus 3 is equal to 0. And we can easily factor this into x minus 3, x minus 1. So the solutions to this are x equals 3 and x equals 1. Well, we already knew that the normal line intersected our curve at the point x equals 1. That was given to us in the problem. So our other point is going to be at x equals 3. So our normal line's equation was negative x plus 2 equals y. So we can find out our y value by y equals negative x plus 2. So y equals negative 1. Therefore, our normal curve intersects the original curve at the point 3, negative 1.